Hello, welcome back to the course. So we are adding new lessons on power measurement and performance analysis of electric vehicle model. So let's start with measuring power as well as efficiency. So we will measure output power as well as input power. So this is the simulation model of the 3 kilowatt DC series motor. Here is the DC series motor which is model, and we have derived the torque speed characteristic of the vehicle for 200 kg weight, right? And that is stored in term of torque and speed in kilometer per hour, right? So use the same signal. We have converted speed from radian per second into kilometer per hour, and for measuring the power, output power, instantaneous output power, we need to multiply torque with the speed. If torque will be in Newton meter and speed is in radian per second, the power will be in watt. So let's use the simple multiplication, product and multiply. Here is our torque output, right, which is coming from the measuring terminal of DC series motor, and speed output, torque multiplied by speed, and we will use scope, right? Name it power, right, or output power. This is mechanical output power. Let's run it. Here is 48 volt DC. There is no current limiting for the limiting starting current, and we can see the performance. Right, we are expecting maximum 3 kilowatt output, so it is reaching 2 kilowatt. Voltage is 48 volt and speed is 67 kilometer per hour. So let's measure the input power. So by comparing input and output, we can have idea about the efficiency. So what we will do, same thing, but we need to use the current and voltage measurement. So we will go to the sim power system library. Under SimScape and under Sim Power System library, you will find specialized technology. Under specialized technology, there is the measurement blocks. So use current measurement block. We can use current and voltage both, but because voltage is fixed, we will use the constant for the voltage. Disconnect this and connect this current measurement block in series like this. This is our measurement terminal output. We will again use the product. So one is current, it will multiply by with the voltage. So for that we require the constant block or voltage terminal from here. So I am using constant block. You can also use voltage measurement terminal, but it will produce the same effect, and we will set the same voltage of battery 48. Yes, so 48 multiplied by the current. Only current is changing, right? And let's observe it and name it input power. So now we are having output power measurement block plus input power measurement block in watt, right? So run it and let's check it. You can observe during starting our power reached up to 6 kilowatt, which is very high. So efficiency was quite less in starting, but now you can see we can compare input power and output power and its difference. So this is how we can calculate power, and for the efficiency, straightforward, we can use block to divide the output by input and multiply by 100. So let's do this. From this block, math operator, we can find the divide block. Here is the divide. So we need to divide output by input. So first we will use output and divide by input power. So the output of this block will be your efficiency. To measure the efficiency, we can do this. We can also use gain multiply by 100, so that we can have efficiency. let's run it. You can see efficiency is 20-30% during starting, but as speed is increasing, it is reaching 54-55 around. So let's observe the final efficiency at maximum speed, steady state speed. Speed is still increasing. We can see at around maximum speed of 67 kilometer per hour. Our efficiency is around 59% only. This is DC motor, right? So let's increase the voltage and check the efficiency, because you can see output power capability is 3 kilowatt and it is operating under its limit. So output is only 2 kilowatt currently, right? 1988 watt, and input is 3 kilowatt, around more than 3 kilowatt. So let's increase the voltage to 60 volt. Remember, we have not used any starting current limiter, so it will go beyond 180 or 200 ampere during starting, but for simulation it is allowable, otherwise we need to use the current limiter. In simulation also we can add current limiter, so the power also will be limited. Starting efficiency will show exact perfect. But let's do it for the 60 volt and let's observe the output power. Now you can see input power reaching during starting to 7 kilowatt. You can see efficiency is going beyond 60. It is currently 62, 63, and top speed is also high because voltage, we increase the voltage. So now you can see at its rated output 3 kilowatt and input is more than 4 kilowatt, near about 5 kilowatt. So 4821 watt and efficiency is 62%. So this is how simply you can measure the output power and input power and efficiency within the simulation, right? So there are so many limitations and assumptions we have made in simulation, but it will plus or minus 3 to 5% variation you can observe in real if you use the proper cooling arrangement for the motor as well as controller. Here we have not calculated even controller efficiency, this is only motor, right? Because straightforward we are supplying power to the motor directly through the battery. So in simulation, if we add the controller and if we add the controller with the thermal model, then also we can calculate the efficiency of controller also. So this is how you can analyze the performance of the motor with power and efficiency within the simulation model. So try to check out the performance of the model you have developed by measuring the efficiency of the model within simulation. Thank you.